Another new molecule this year is esters. These are formed by what's called a condensation reaction between both an alcohol and either a carboxylic acid or an acid chloride. And they've got the functional group, they've got a carbon that is bonded to two O's, it's got a double bond to one O, and a single bond to another O. And then these R's, again, these are just any length of carbon chain, they can be anything. So, for example, if you had ethanoic acid here, which is a carboxylic acid, and methanol, which is an alcohol, you would react it with concentrated sulfuric acid and heat, and it would form the ester methyl ethanoate because so the suffix is "-ile" and then "anoate." So the first word methyl that comes from the alcohol, and the anoate is going to come from the acid. So the "-ile" anoate, you just got to remember "-ile" is the alcohol, anoate is the acid. And the reason this is called what's called a condensation reaction is because a small molecule is lost from the larger molecule to form, oh, sorry, a small molecule is lost to form a larger molecule. So in this case, water is eliminated because the way this functional group, the way this COO bond actually forms between the two is that the ethanoic acid is going to lose the OH of its functional group, and the alcohol is going to lose the H, and then these join together and form water. So it's called condensation because water is lost when it forms. And so you can see here, this is where the ethanoic acid was. So it's got the two carbon chain, and here is where the functional group used to be, and it's lost its OH. And then here is the methanol, and it's bonded to an O, and the O has lost the H atom, and so these have joined together to form the C double bond O, and it's also going to form water as well. So you heat this with the sulfuric acid, and which will catalyze the reaction, and you heat it under reflux. And you heat it under reflux because esters are volatile, so they evaporate really easily. So you have to heat it under reflux so that you don't lose your product because then you're going to lose all of the ester that you formed. And then after you have to add sodium carbonate just to neutralize the sulfuric acid because sodium carbonate is a base. Okay, now that we know how to form esters, let's talk about some reactions of esters. So, esters will undergo hydrolysis, which is where they're split by adding water. If you think about it, lysis means split, hydro is water, so hydrolysis is hydrolysis split with water. So, if that helps you to remember it. And they're going to be split at the single bond to the O, if you look here in this molecule that connects the two carbon chains from the acid and the alcohol. So they're going to be split at this O, and in acidic conditions, if you split using water in acidic conditions, it's going to form the alcohol and the acid, the original that formed the ester. So for example, methyl ethanoate from the previous example, if you add H2O, if you add water in acidic conditions, which is just what this means, or it could be just an acid, like hydrochloric acid, it's going to form the acid and the alcohol because the OH from the water is going to be added, it's going to be split here at where the carbons are connected, and then the OH from the from the water is going to be added to this carbon to form ethanoic acid, and the H from the water is going to be added to this side of the molecule to form methanol. In basic conditions, it will be slightly different. It's going to form the alcohol as well, and also the carboxylate ion, which is just going to be the acid without the H on the oh, it's the other way around, without the H um, on the normal OH group. So here you can see just water in basic conditions or just a base. It might be written like this too. Um, it's gonna add the OH, it's gonna add the H to the alcohol side here to form the alcohol, and it's gonna add the O to the acid side to form the carboxylate ion. So that's just gonna be um, I think this one's written the wrong way around. But the minus is actually meant to be up here, but oh well, that's all right. Just remember the minus is up here, because it doesn't have the H atom. So if you think about it, that's just because if you think about um, the OH, it's well the H2O, it's just adding this OH ion. So the O is added to this side to form the ion, and the H is added to the other side to form the alcohol. A real-world example where you'd find esters is in fats and oils. These are what's called triesters of a molecule called glycerol. Glycerol is just the name for this molecule, which is you could also call propan 1,2,3 triol. And it's formed between a triester of glycerol and a long chain carboxylic acid, which you can also call a fatty acid, and it forms an ester linkage between each fatty acid and each OH of the glycerol. So it's called a propan 1,2,3 triol, so it's got three OH groups. So if you look here, this is glycerol. It's got a three carbon chain, and each carbon has its own OH group, so it's drawn vertically. And then it's going to form that ester linkage between each of these OH groups with the fatty acid chain. So you can see here it forms the ester linkage, and these are just any different carbon chain. The dash means they can be different. So the three fatty acids, they don't need to be the same. They can be, but they don't have to be. And to form the triglyceride, you just heat the glycerol with the three, and it'll form the ester linkage. And these are heated under reflux because esters are volatile. And again, this is a condensation reaction because this is going to make three waters. So three water molecules are going to be lost to form the larger triglyceride. Saponification is just the name for the alkaline hydrolysis or the basic hydrolysis. So remember, hydrolysis in basic conditions of glycerol triesters using NaOH. And the carboxylate ion that's gonna be formed is soap, because remember, if you undergo hydrolysis in basic conditions, it's gonna form the ion instead of the acid. So here, if you have this triester, for example, it's got you've got the three ester linkages, and here are the three fatty chains. In this case, these are all the same, but remember they don't always have to be the same. And they're very long. They've got 17 carbons. You add the NaOH, and it's going to be split at these ester linkages and form the carboxylate ion, which is going to be the three carboxylate ions with the three different fatty chains. In this case, they're the same, and the ion, because it's split from the glycerol, and then it's going to form the alcohol, which in this case was glycerol. So the fatty chain of the soap that's formed is called hydrophobic because it's non-polar. So it's gonna repel water because water's polar, and if you remember from level 2, like attracts like. So it's gonna repel the water because it's non-polar, and the carboxylate end, this end of the ion, is hydrophilic because of the polar bonds here.